So for section 3.2, page 15 of module 2, we have the definition. Given the conditional statement, if P then Q, we call the statement, if not P, then not Q, the inverse of if P then Q. The statement, if Q then P, is the converse of if P then Q. And the statement, if not Q, then not P, is the contrapositive of the statement, if P, then Q. So now it's time to construct our truth table for our statements, the inverse, converse, and the contrapositive. To make it easy for us, it is better that we have a separate column for not P and another column for not Q. After which, we'll have to establish our observations. So let's take all the possibilities for the truth values of P and Q, and then we'll have to evaluate our if P then Q. It's only false when we have if true then false. Then let's look at the converse, if Q then P. And again, to get not P, we just have to negate all the values in the columns of P. The same thing with not Q, just negate all the values in the columns of Q. Now, for inverse, we just have to look at the columns not P and the column for not Q and apply the rules of the conditional statements. Okay, so the same thing with our contrapositive, we just do the otherwise. We have to evaluate not Q, if not Q, then not P. Now observe the green columns. They have the same truth values. So we say that these columns are logically equivalent. Okay, so we say that a conditional statement, if P then Q, is equivalent to its contrapositive, if not Q, then not P. In your observation, look at that. In the orange columns, we see that the inverse and the converse have exactly the same truth values. So therefore, they are logically equivalent, meaning the converse is not equivalent to the conditional statements. So we say that a converse, if Q then P, of a conditional statement, if P then Q, is equivalent to its inverse, which is if not P, then not Q. Okay, so if you look at this, the truth table, we see that if P then Q is never equivalent to if not Q, if is never equivalent to if Q then P. Okay. So for example 3.2, we are given the statement, all even numbers are divisible by 2, and we are to formulate its conditional statement and then to give its equivalent converse, inverse, and contrapositive. So how do we do this? First step is we have to break down the statement into two separate statements. Okay, so all even numbers and the statement divisible by 2. So we have to let P be a number is even, and then let Q be the statement a number is divisible by 2. And then the conditional statement says that if P then Q, so if a number is even, then it is divisible by 2. Or if a number is even, then the number is divisible by 2. Just the same meaning, just the same sense. Okay, the next would be the converse. Now what's the converse again? It's the statement if Q then P. So if a number is divisible by 2, then it is even, or if a number is divisible by 2, then it is an even number. After that, we'll do the inverse. It's equivalent to the converse, so if not P, then not Q. If a number is not even, then it is not divisible by 2. Or if a number is not even, then the number is not divisible by 2. Finally, we get the contrapositive, which is equivalent to our conditional statement. So it is if not Q, then not P. If a number is not divisible by 2, then it is not even. Or if a number is not divisible by 2, then it is not an even number. Okay, so that's it.